Hmm? Okay. So today, before starting today's class, two things we need to know. First of all, one is called mole fraction. One is called mole fraction. Already I discussed about this. Now, what is mole fraction? Mole fraction. Tell, Asmita, tell what is mole fraction.
Number of moles of a particular substance divided by number of moles of the total substance in the solution.
Number of moles of the component divided by total moles, right? That mole fraction. Okay, like if a solution, like if I take a solution, and in this solution, solute mole is Na, and solvent mole is Nb, then mole fraction of A will be Na divided by Na plus Nb. Clear? And so mole fraction of B will be Nb divided by Na plus Nb. Clear? Understood, service? Like like here, if I ask you that how many boys in this class, so you will tell sir 2 by 4 or 1 by 2. Okay, how many? What is the fraction of boys in this classroom? That you will tell sir 2 by 4. That number of boys in the classroom divided by total number of students, right? So like that, mole fraction is equals to what mole fraction we are asking, that number of moles divided by total moles. Clear? Do you have any doubt, anyone? Another thing I told, that mole fraction of the component will be equal to 1, and ratio of mole fraction will be equal to the ratio of number of moles, right? Ratio of mole fraction will be equal to the ratio of number of moles. Now, next, another point I told, that is molality. Molality. What is molality? We denoted in small m. Tell, Aditya, tell. What is molality?
Number of moles divided by kg.
That what is like small m? That number of moles of sol, number of moles of solute. Hmm. 1 kg of what?
Solvent.
Then mass of solvent. Mass of solvent in kg. Okay. Mass of solvent in kg. Clear? So the unit of molality will be mole per kg. Clear? What does it mean? It means that in 1 kg of solvent, how much moles of solute is there? So sometimes it is not in kg. So number of moles by mass of solvent, it will be in gram multiplied with 1000. Yes or no? This is the formula I told. Clear? Yes or no? So anyone have any doubt regarding mole fraction or molality? Any doubt? Okay. So today we are going to start colligative property. Okay, last topic is of this chapter, that is called colligative property. Now, what is colligative properties? Colligative property is, sir, it is not colgate or something. It is colligative property. Colligative property means like uh, if I ask you that you mix salt, you take a water, okay, you took water, you add salt, and another water you add sugar. Clear? The taste will be same or different? Taste will be different, right? How it is? Why it is different? Because salt property is different and sugar property is different, right? Sugar taste is different, salt taste is different. So that the taste is a property which depends on the properties of the solute, right? Which depends on the properties of the solute. But colligative property is one that kind of properties which doesn't depend on the properties of solute particles. It depends only on the number of solute particles. Clear? It depends on the number of solute particles. Okay, like if I take water, okay, and I add 1 spoon of salt, 1 spoon of salt, okay, the boiling point of water will increase. If I use 2 spoons of salt, the boiling point of water will more increase. So this increase in boiling point, this increase in boiling point is a colligative property. Understood what is colligative property? Colligative means depend on numbers. Depend on numbers. Okay. Colligative means depend on numbers. So what is colligative property? Colligative property means the properties of solution, the properties of solution which depends only on the number of which depends only on the number of solute particle irrespective of irrespective of their nature. Clear? Okay, are called colligative property. Colligative property. Now it's a very simple thing. Hello? Hello, am I audible?
Yes, sir.
Yeah. It's a very simple thing. Like if I add instead of salt, if I add 1 spoon of sugar also, the boiling point also increase. That is the thing. It doesn't depend on the what what is the nature of the solute. It depends only on the number of the solute. The more number you add, the change is more. Clear? Yes or no? Now you will tell, sir, what properties are there? Actually, there are four properties. Four properties. First property is called relative lowering of vapor pressure, RLVP. Second property we will discuss, that is called elevation of boiling point, EBP. Third property, depression of freezing point. And last property is called osmotic pressure. Okay, osmotic pressure. Clear? This four property we will discuss. Apart from them, there are many colligative properties are there. But these four property we will mainly discuss in this chapter. Clear? Clear or no? So understood what is colligative property? Kirti. Sarvesh. Understood what is colligative property? Colligative property means that properties which depends only on number of the solute particle, doesn't depend on the nature of the solute particle. Okay. So first is called relative lowering of vapor pressure. First property we'll discuss, that is relative lowering lowering of vapor pressure. Now we'll tell, sir, to big name it is. Okay, relative lowering of vapor pressure. So we will divide it in a small way. So tell me, what is vapor pressure? Last class I told you that what is vapor pressure. Tell, what is vapor pressure?
Pressure exerted by the vapors.
Pressure exerted by
Vapors.
vapors. No, wrong. What is vapor pressure? Pressure exerted by vapor, but in a solution, like how can you explain vapor pressure?
Vapor pressure of solute plus solvent.
Hmm. Acha, listen. What is vapor pressure? I am explaining again. Listen carefully. So first of all, vapor pressure means like if you take a solution, if you take a solvent, okay, if you take a solvent and close it, some vapor will come here, and due to this vapor, some pressure will come, right? Yes or no? So that is called vapor pressure. Okay, that is called vapor pressure. Okay, yes or no? Now, when there is pure solvent, I'm telling you, listen. When there is pure solvent, okay, pure solvent. This is pure solvent, pure solvent. Now, let's suppose the pure solvent have a vapor pressure. Yes or no? Let's, like pure water is there. Pure solvent have a vapor pressure. Let's say the pure vapor pressure of pure solvent is P naught. Okay. If what is that? P naught of solvent. Clear? Now, after that, I add solute particle in it, and I will make a solution. I add solute particle in it. I add solute particle, and I make a solution. So what will happen? See, when you add solute particle, the liquid of solvent are unable to go outside. Yes or no? Yes or no? The liquid of the solvent is unable to go outside. Okay, clear? Yes or no? This thing understood? Yes or no? When you make a solvent and make some solute particles or whatever, the liquid particles will unable to come outside. So when it is unable to come outside, the vapor pressure here will be more than the pure solvent, or will be less than the pure solvent?
More.
More than pure solvent. The vapor pressure of the solution will be more than the pure solvent or less than the pure solvent? Simply, very simple thing. Like you are running, okay? You are running normally, very fast, okay? But I am or I'm holding you with a rope, okay? You are here and you are running. Your speed, let's suppose V, and I am holding you with a rope. In the next case, your speed will be V dash. Tell me which case speed is more? V dash speed is more or V speed is more? V. So similarly, when pure solvent is there, okay, that solvent, pure solvent pressure, let's suppose P naught solvent, okay, pure solvent pressure is P naught solvent, okay, and the solution pressure is P solution. Tell me which one is more? P solution is more or P naught solvent is more? Tell me. P naught solvent is more. Okay. Now, according to Raoult's law, what Raoult's law told? That P solvent is equals to P naught solvent into P solvent is equals to P naught solvent into mole fraction of the solvent. Yes or no? Yes or no? P solvent is equals to P naught solvent into mole fraction of solvent. Okay. Now, how much extra? Now tell me how much extra low, like the vapor pressure is low. So I can tell that delta P of solvent is equals to that initially it was there P naught solvent minus final pressure of the solvent. Yes or no? Initially, this is the solvent pressure and this is the final pressure. This much extra, it is low. The lowering happened. Okay. So this is called lowering of vapor pressure. This is called lowering of vapor pressure. This is not colligative property. Remember, this is not colligative property. Lowering of vapor pressure is not colligative property. Clear? This thing understood? Okay. Now, now coming back to this understood any doubt?
Why it is not
Uh,
colligative?
it is not a colligative property because it doesn't depend on the number of the solvent, number of the solute. Is it depend on the number of the solute? Tell. Pressure, both pressure we can calculate. No, no, no. Directly, did you get any expression here that you can say that this is depend on the number of solute? This is a difference. This is a simple difference. Okay. Now, now, relative lowering of vapor pressure. What is relative lowering of vapor pressure? Relative lowering of vapor pressure. Now, see, this is lowering of vapor pressure P naught minus P. Yes or no? With relative to P naught, like with respect to P naught, how much lowering is there? That is equals to that is equals to, we can say that is a colligative property. How? Listen. So this thing P naught minus P equal to P naught is relative lowering of vapor pressure. Achha, can I write this P naught by P naught? Yes or no? Minus P by P naught. Yes or no? Tell. Mathematics. Okay. Achha, P naught by P naught equal to 1 minus P by P naught equal to, tell, who can say what is the value of P by P naught?
Mole fraction of solid.
Very good. So P is equals to, P naught into mole fraction. So mole fraction is equals to P by P naught. Now mole fraction of what? Solvent, right? Yes or no? So mole fraction of solvent. So 1 minus mole fraction of solvent means mole fraction of solute. And mole fraction of solute is equals to number of solute divided by number of solvent plus number of moles of solute. So see, relative lowering of vapor pressure is equals to numbers. It depends on the number of solute. Clear or not? Clear or not? Tell.
Yes, sir.
Okay. So actually, what is the formula I am writing here? That relative lowering of vapor pressure is equals to P naught minus P by P naught is equals to I into mole fraction of solute. Now you will tell, sir, what is I? What is I? I is called Van 't Hoff factor. This we will learn in the last after all the properties. Just remember what is I? I is Van 't Hoff factor. Okay, clear? Clear, clear or not?
Yes, sir.
Okay. Now, in your exam, what kind of question they will ask? They will ask that determine the molar mass of solute. Determine the molar mass of solute. Molar mass of solute. Okay. So, see, for dilute solution, number of moles of solute is very, very low than number of moles of solvent. Yes or no? For dilute solution, number of moles of solute is very low than number of moles of solvent. So can I write P naught minus P by P naught is equals to generally what? N of solute divided by N of solvent plus N of solute. Yes or no? So because the number of solute is very low, the addition we can say this is equals to, we can say N of solute divided by N of solvent. Yes or no? Tell. Okay.
Yes, sir.
N of solute by N of solvent. Now P naught minus P by P naught. N of solute means given mass of solute. Yes or no? Divided by molar mass of solute. And N of solvent means given mass of solvent divided by molar mass of solvent. Here. So from here they will ask this value. What is the molar mass of solute? Here. Question will be asked like this. Clear or not? Tell.
Yes, sir.
Any doubt? Kitty? Sarvesh, any doubt? Tell. Hello? So what is the formula? P naught minus P. P naught minus P equal to minus P by P naught equal to I into X of solute. Okay, mole fraction of solute. What is I? I is Van 't Hoff factor. I'll talk about this later on. Okay, generally remember I equal to 1. Normal solution. Okay, non-volatile solute is I equal to 1. Okay, I'll give you the values also. Should I give you one question? Okay, so the question is an aqueous solution. Aqueous solution of 2% non-volatile solute, 2% non-volatile solute exerts a pressure exerts a pressure 1.004 bar at the normal boiling point of solvent. At the normal boiling point of solvent. What is the molar mass of solute? What is the molar mass of solute? I am giving you 5 minutes. Try. Listen. Hello?
Brought it to last phase extinction.
Okay, listen. Listen first. What happened? First of all, you need to understand what is boiling point of solvent. Remember, boiling, this is an NCERT question. Okay, NCERT question. What is boiling point? Boiling point means when vapor pressure of solution will be equal to the atmospheric pressure, right? When vapor pressure of solution will become atmospheric pressure, that is called, that temperature is called boiling point. Okay. Now, what is the question telling here? Simple question, sir. I have a solution. Okay, I have a solution, solvent. Not in boiling point, the pressure will be 1 atmosphere. Yes or no? When boiling point of this solvent, the pressure should be 1 atmosphere. Yes or no? Because our atmospheric pressure is 1 atmosphere. So P naught is equals to 1 atmosphere. Achha, 1 atmosphere equal to how much bar? 1.013 bar. Clear? Now I add some solute. I add some solute. When it comes to its boiling point, it's showing the pressure that 1.004. So the pressure lower. Okay, the pressure become low when I add some solute. How much low? So this is the value of P. Yes or no? Now we know that P naught minus P by P naught is equals to W1 by M1 into W2 by M2. Yes or no? We just need to find out M1. Yes or no? Clear? Tell me, understood or not?
Yes,
Now, all of you tell, what is W1? No. What is the mass of solute?
mass is
Tell. Are 2% given na here. What are you doing? So mass of solute is 2 gram. Okay. What is mass of solvent? 100 gram. Clear? What is the mass of molar mass of solvent? 18. Water na? 18 gram per mole. And they are asking what is M1. Just put the value, you will get the answer. So if I put the value, so I will get P naught. P naught value is 1.013 minus 1.004 divided by 1.013 equal to W1 is 2 into 18 divided by M1 into W2 value is 98. So if we calculate all of them, all the things, you will get M1 value is equals to 41.35. Clear? Clear or not? Tell.
yes,
Clear how you are getting?
yes.
Another I should I give? Understood how to do? Okay. Another question I'm giving you.
Sir, we just take it.
Huh?
So we'll take this question.
Hmm. Okay, done.
1 minute. Yes, sir.
That's it. Okay, am I audible?
Yes.
So I'm giving one question. Right? Question is calculate the vapor pressure, vapor pressure lowering. Okay, lowering, lowering of vapor pressure caused by addition of 50 gram 50 gram of sucrose. Okay, 50 gram of sucrose. Sucrose molecular weight is 342. Okay, 50 gram of sucrose to 500 gram of water. Okay, if the vapor pressure water, if the vapor pressure of pure water at 25 degrees Celsius, at 25 degrees Celsius is 23.8 millimeter Hg, and I value is equals to 1. Calculate. Tell. What you need to find out? Delta P value. Okay. Simple question. Very easy question. Tell. Tell. Tell what is the answer? Easy question. Just think about it. What they're asking delta P. Okay. What we know, delta P means P naught minus P, right? So P naught minus P by P naught is equals to mole fraction of solvent. Yes or no?
Sir, is it like 1190 to 10 power minus 4 mm?
Okay, let's see. Okay, so mole fraction.
0.1.
Okay, so mole fraction of solvent. So mole fraction of solvent means N of solvent divided by N of solute. Sorry, N not N of solvent, N of solute. Okay, solute. N of solute plus N of solvent. Right. Now they are asking this value. So P naught minus P is equals to N of solute. What is the N of solute? 50 by 342. Yes or no? 50 by 342 divided by N of solute, again 50 by 342, minus plus N of solvent. N of solvent is, then N of solvent is 500 by 18 multiplied with P naught. What is the P naught value? 23.8. Yes or no? This is they are asking. Am I right? All of you gone through this? Yeah. So how much you are
Yes,
getting? How much you are getting?
so approximately 0.9.
Hmm?
Sir, 23.6, 23.7,
If
sir.
you listen, if you calculate all of them, you will get around value 0.124. Okay, 0.124 millimeter H. Clear? This value they are asking. Total value they are asking. They are not asking P value. Okay, they are asking P naught minus P value. Clear? Okay.
Yes,
If
sir.
they ask what is the final pressure of the solution, then you can do that. Then you can do that 23.8 minus 0.124. That is the final pressure of the solution. Clear or not? Tell. Okay.
Yes.
Next property we are going, that is called elevation of boiling point. Elevation of boiling point. Very simple. Elevation of boiling point. So you take a solvent. You take a, let's suppose water I take. Okay. What is the boiling point of water? 100 degrees Celsius. Okay. What is the boiling point of water? 100 degrees Celsius. You add some solute in it. Let's suppose you add some salt in it. You add some salt in it. The boiling point will increase. You can check in your home that after adding salt, boiling point will increase 100. It will increase to 110 degree. I'm saying, just saying. Okay, you can say, you can check it in your home that normally you are boiling. How much time to take to boil one glass of water? It will take more time to boil if you add some salt in it. Understood?
Yes, sir.
Okay. So 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 normally if you add solute, what will happen? Boiling point will increase. Okay, so elevation of boiling point happen, and that property depends on the number of salt. Okay, so now first of all, I already told you what is boiling point. Boiling point means boiling point at that temperature. Boiling point at that temperature means atmospheric pressure. Remember, atmospheric pressure will be equal to vapor pressure of solvent. Okay, vapor pressure of solution. Okay, Acha, let's suppose you are taking a solution. You are taking a solvent. Okay, this is the pure solvent. Pure solvent boiling point, let's say TB naught. Okay, temperature of boiling point naught. This is for pure solvent. Pure solvent for water it is 100 degrees Celsius. Okay, now if I add some solute, after that the boiling point will increase. It will become TB. Okay, so that TB is the boiling point of solution. Boiling point of solution. Okay, so how much elevation of boiling point? Elevation of boiling point. How much elevation of boiling point? So I can write down delta TB is equals to solution minus solvent, pure solvent. Yes or no?
Yes, sir.
Yes or no? Tell. This thing understood?
Yes, sir.
Delta TB is equals to TB minus TB naught. Clear? Now, graphically also you can understood this thing. For example, see what happened. Let's suppose this is the boiling point of pure solvent. Okay, boiling point of pure solvent. I'm writing the graph between vapor pressure versus temperature. I'm drawing the graph between vapor pressure and temperature. So this is the boiling point of TV now. And after adding, this is the boiling point of the solution. Yes or no? This is the boiling point of the solution. So when you check the vapor pressure now, the solvent vapor pressure will look like this. The graph look like this. And the solution vapor pressure will graph look like this. Okay. So vapor pressure, if I extrapolate this, then the vapor pressure will touch here. Yes or no? Tell me, what is the value of this vapor pressure here? It will be 1 atmosphere. Yes or no? It will be 1 atmosphere or 1.013 bar. This will be fixed always. Yes or no? That vapor pressure at boiling point should be fixed always. Tell yes or no? Because boiling point always vapor pressure will be fixed as atmospheric pressure. So this is also one. But after that we are checking that this temperature increase. Okay, this temperature increase. So this is for solution, solvent, and this is for solution. Clear or not? This thing understood or not? And this difference is nothing but delta TB. Okay, this difference is nothing but delta TB. Okay, so we are going to calculate delta TB. Now, experimentally, we did that delta TB is directly proportional to molality of the solution. Directly proportional to the molality of the solution. Clear?
Yes, sir.
Okay, so I have to molality in it, no doubt, right? Molality, no doubt. So, delta TB, I have to remove the proportionality sign. So, delta TB is equals to I into KB into M. Now you can say, what is I, what is KB, what is M? I already told I is Van der factor. That value will be given, that I will discuss. Okay, Van der factor. Now what is KB? Listen, what is KB? KB is very important thing. KB known as boiling point elevation constant. Boiling point elevation constant, or molal elevation constant, or molal molal elevation constant, elevation constant, or ebuloscopic constant. Mostly this name will be given ebuloscopic constant. Okay, all are the same thing called KB. KB is a constant. Okay, KB is a constant, or you can say boiling point elevation constant. Okay, so KB value given. Can anyone tell what is the unit? What is the unit of KB? Sometime question asked. What is the unit of KB? Let's see who can tell. What is the unit of KB? Tell. Hmm? Aditya, what happened? What is the unit of KB?
Normality.
Hmm?
Mole equals kg.
Tell. As KB equal to, I can write like this, na? Delta TB by I into M. Achha, I doesn't have any unit. Okay, I is a value, is a constant. I doesn't have any unit. T temperature unit is Kelvin. Yes or no? And molality unit is mole per kg. So what is the KB unit? Kelvin kg per mole. Yes or no?
Yes, sir.
Understood? Important. This is important. What is the unit of KB? Clear or not?
Yes, sir.
Okay, Kelvin kg per mole. Okay, so that is the that is the KB. Now, understood. So what is the elevation? What is the elevation constant? What is the what is ebuloscopic Ebuloscopic constant. So sometimes they ask that what is ebuloscopic constant. Acha, we know that delta TB is equals to Kb into M, I into Kb into M. So if I equal to 1 and molality equal to 1, then delta TB is equals to Kb. Okay, so what does it mean? When you take 1 mole solute, when you take 1 mole solute, 1 mole solute, and you dissolve it in 1 kg solvent, how much boiling point increase? That is known as Kb. Clear? Understood? Or for 1 mole or 1 molar solution, how much boiling point increase? That is called Kb. Clear? Now from here, what kind of question? Again, they will ask mass of solute, molar mass of solute. How to get molar mass of solute? Delta TB is equals to I into Kb into M. Okay, I into Kb into M. Now, that Kb value, I value, I will separate. I into Kb. Acha, what is the molality? Molality means mass of solute by, you can say moles of solute. So moles of solute means given mass by molar mass. Yes or no? Moles of solute into mass of solvent, and obviously given in gram. So 1000. Clear? Yes or no? So here delta TB given, Kb value given, I value given. So we can easily find out mass of solute. Yes or no? Tell.
Yes.
So remember this equation. The delta TB is equals to I into Kb into mass of solute into 1000 by M of solute into W of solvent. Okay. So can I give you a question? Tell. Understood this? Okay, I'm giving you a question. Easy question. Okay. Do boiling point of water. Okay. At 750 millimeter Hg. At 750 millimeter Hg is 99.63 degrees Celsius. Okay. How much sucrose? How much sucrose is to be added? Is to be added to 500 gram of water. 500 gram of water, such that it boils at 100 degrees. Such that it boils at 100 degrees Celsius. Okay. Kb value of water given. Kb of water given 0.52 Kelvin kg mole inverse. Okay. And I value 1. Go ahead. I'm giving you 5 minutes. Listen. What is given here? What is given here? Simply boiling point, elevation of boiling point. How much? Tell me. What is the delta TB? Delta TB given?
0.37.
100 minus 99.63. So equal to how much? 0.37. Okay. 0.37 Kelvin. Clear or not? 0.37 Kelvin. Huh? Asa, listen one thing. Difference in Kelvin and difference in degree Celsius will be same. Simply if I ask you 110 degrees Celsius minus 100 degrees Celsius equal to how much? 10 degrees Celsius. Yes or no? As 110 degrees Celsius means how much Kelvin? 283 Kelvin minus 273 Kelvin. Sorry, 383, 373 equal to how much? 10. So difference always be same. Okay, value should not be same. But if you take the difference, always be the Kelvin and degree Celsius always be same. Clear?
Yes, sir.
So Kb is equals to 0.52 Kelvin kg mole inverse given. Okay. As a M of sucrose given, that is 340 M2. M2 given 342 gram mole inverse. Okay. Now we know delta TB is equals to I into Kb into mass of sucrose divided by molar mass of sucrose 342. Okay, mass of sucrose divided by molar mass of sucrose into weight of water. What is the weight of water here? What is the mass of water? 500 gram. Okay, into 1000. Yes or no? 500 gram into 1000. So if you put the value of Kb, Kb value given 0.52, Kb value, I value also given 1. So Kb value if I put 0.52, so you will get the value. Finally, all you calculate, then you will get the value W1 is equals to 121.7 gram. Okay, 121.67 something. Okay, clear or not? Understood everyone how to do? Simply you have formula, just from the equation you just deduce the, you have to deduce the data, then you will get the answer. Clear? Clear? Next, next, next property, same as boiling point, called depression of freezing point. Depression of freezing point. Nowadays, you know, summer is coming. All of you like ice cream, right? How many of you like ice cream? Most of you like ice cream, I think so. Okay, summertime we eat ice cream. So have you saw any ice cream shop or anywhere where is some big like a big portion of ice is there? Okay, some ice cream factories are there. You can see that when the big portions of ice are there, they put some dust particle of, on the surface of the ice, some dust particle. Okay, why? Or else you can try it in home also. You take a glass of water and put it into deep freezer. Okay, and after take it out when it become ice, and you take a salt water. You take salt water. Okay, salt water, and deep freeze it and become take that ice. You will check that this ice, okay, this ice will melt at 0 degrees Celsius, but this ice will melt at minus 10 degrees Celsius. Understood? Okay, so melting point or freezing point will decrease. Understood? Melting point or freezing point will decrease if I add solute into it. Like now understood one thing. Boiling point will increase. Melting point will decrease. Clear? Boiling point will increase. Melting point will decrease. Simple thing. Like if I take a solvent, let's suppose its pure melting point is a pure freezing point is TF. Melting point, freezing point, same thing. TF not. If I add solute into it, if I add solute into it, so what will happen? It the final temperature volume, final freezing point will become TF. So delta TF equal to which one is bigger? Tell me. TF not is bigger or TF bigger? Obviously TF not bigger. Yes or no? TF not. Okay, like TF for water, TF naught is 0 degrees Celsius. Okay, and if I add, the TF become minus 10. So which one is bigger? Obviously TF naught. So delta TF equal to TF naught minus TF. Okay, so again, experimentally when we check that TF is directly proportional to molality of the solution. So delta TF is equals to I into KF into M. So like there we find out KB, here KF. What is KF? KF is equals to freezing point depression constant, known as freezing point depression constant, depression constant, or molar depression constant, molar depression constant, molar depression constant, or cryoscopic constant, known as cryoscopic constant. Now tell me, what is the unit of KF? What is the unit of KF? Tell. What is the unit of KF? Huh? Same. Kelvin. kg per mole. Yes or no? Kelvin kg per mole. From here also I can write that delta TF is equals to I into kb into W of solute, given mass of solute, and molar mass of solute multiplied by given mass of solvent. If it is giving in gram, multiplied with 1000. Clear? Yes or no? Okay. So okay, now you will tell, sir, this K value, KB value, how they are, how we are getting. This is an experimental value, but we have to calculate that value. Remember, two formula I am writing. Okay, this not that very much important, but remember this thing. Okay, because in NCERT it is given, so you have to remember this. So Kf, to calculate Kf is equals to R into m of solvent, mass of solvent, into TF. Okay, the boiling point square, divided by 1000 into delta H, fusion, enthalpy of fusion. Okay, into delta H of fusion. Clear or not? Okay, now what is this? What is this delta H of fusion? Delta H of is an enthalpy change. Like you, fusion means, you know what is fusion? Vaporization, fusion. You know, vaporization means liquid to vapor. Fusion means liquid to solid. Clear? Fusion means liquid to solid. And what is R? R is universal gas constant. You know, R is nothing but universal gas constant. Okay, so so here TF is, so this is how KF and KB calculated. Question generally like not ever asked. Just remember that how to calculate this. Clear? Molar mass, capital M molar mass. Okay, clear? Should I give another question? So question is that a 5% solution, a 5% solution by mass, 5% solution by mass of cane sugar, cane sugar, okay, in water has freezing point, has freezing point 271 Kelvin. Okay, calculate calculate the freezing point, calculate the freezing point of a 5% glucose in water, 5% glucose in water. If freezing point of, if freezing point of pure water, pure water is equals to 273.15 Kelvin. It's a big question. Okay, I'm giving you for 6 minutes. Let's see you can tell or not. Okay, read the question at least 3 to 4 times. Okay, so what is given here? First of all, we have to find out the delta TF. What is the delta TF given? 273 minus 271. I can 0.15. Forget about 0.15. Okay, 2 Kelvin. Clear or not? Now, what is the molality of cane sugar solution? Molality of cane sugar solution. So, molality of cane sugar solution is number of moles of sugar. What is that? 5 gram. Okay. Molar mass of sugar 342 gram. Clear? Number of mass of sugar. Number of mass of solvent. Tell what is the mass of solvent here?
100.
Ah, 95. Okay. Into 1000. So if you calculate, you will get 0.154 molar. Okay. Now we know delta TF is equals to KF into molality. So KF value you will get 0.154 by 0.154 by 2. That's it. Let it be. No need to do anything. Clear? Oh, sorry. Reverse. M already equal to 2 by 0.15. Okay. Clear? Kelvin, kg, mole inverse. Yes or no? Understood? Yes or no? Now, same thing I have to do for glucose. Same thing I have to do for glucose. So for glucose, Kf value will be same. Yes or no? So delta Tf I need to find out for glucose. So Kf into molality. So what is the Kf value? Kf value given 2 by 0.154. What is the molality? Molality is again 5% glucose. So 5% glucose means 5 by 180 into 1000 by 95. Yes or no? Tell yes or no. Okay. So when you calculate all the things, delta TF value you will get 4 Kelvin. Delta TF value you will get 4 Kelvin. So what is the TF of glucose solution? So TB TF naught. Okay. TF naught minus 4 Kelvin. TF naught TF naught minus 4 Kelvin. So what is the TF naught value? 273.15 or 273 minus 4 is equals to 269 Kelvin. Clear? Clear or not? Okay. See, K is nothing but solvent K. It's not a solution. Here, for one solution, K we are talking about for solvent. Yes or no? So, if I add cane sugar, if I add glucose, okay, every case the boiling point will decrease. Yes or no? Every case the boiling point will decrease. And how it will decrease? It depends only on the number of solution. Solute particle. Clear? See, here what is the number of moles? 5 by 342. Here what is the number of moles? 5 by 180. Where is the high number of moles? For glucose it is high. That's why freezing point less. Understood? This is the chemistry behind it. Understood or not? Tell. Okay, clear? Understood? Sarvesh?
Yes, sir.
Okay. Ashmita, Kirti.
Yes, sir.
Okay. One more is there that is called osmotic pressure. Okay. First, yeah, I'll give you some questions on this. You practice osmotic pressure. We will do in the next day. Clear? Osmotic pressure and Van't factor remaining that we will do in the next day, and we'll complete that too also, and then we'll start electrochemistry. Clear? Tell any doubt till now? Anyone anything regarding any doubt?